Hello and welcome back to my series on algorithms. After many, many years of being away, I'm finally revisiting this adventure of conquering LeetCode. It's not my first attempt, but this time feels different. I'm reteaching myself, and this time I'm documenting the process so I could review the lessons after, and hopefully someone out there gets value out of this. They say there's no better way to learn than teach, and I love to learn. So yeah, today I want to walk you through a problem I was given. It's a hard problem, from what I could tell, on LeetCode, and I was not happy at all with my performance. Again, I have never done live coding to get a job yet in my career. It was always word of mouth, like, hey, this guy's really good, hire him, and it was flattering, and the work always came from word of mouth. So I'm actually very excited to be sort of challenged this way. And I'm really enjoying the process, except for the sort of embarrassing moments where you realize you need more practice. But in any case, the interviewers are there. The interviewers are there to do their job. They just want to see how you think as an engineer, think as a software developer. And I was also given a bit of poor advice. So I had studied and gone through many subjects besides medium and harder algorithm problems, and where I should have just focused on algorithms. So if any I almost think it's unfair that an interviewer doesn't tell you what's on the interview. I really do. There are so many subjects out there, and it's your job to be prepared on what the job description is, and I think the interviewer's job to tell you what's on it. So in any case, no excuses. Let's get into it. So this was a consecutive subarray problem, or a consecutive sum with target. So given an array of integers and a target value, determine whether there exists a contiguous subarray, a sequence of consecutive elements whose elements sum up to exactly the target. Now, I'm kind of, in my nerves, skipped over the fact that it's consecutive. That's a really important part here. So obviously consecutive means the numbers have to be back to back in some consecutive sequence, 1, 2, or 3, or 2, 3, and 4. But it cannot be 1, 3, and 5. Of course, they have to be consecutive elements. That's a super important, and it's the name of the problem. So it just goes to show my nerves that I didn't catch it. I eventually saw that, but not right away. So we're given some array with a target. And I went ahead and asked AI actually to write me up a method template with 5 tests with the target or the array, the array of integers, a target, and the answers. So I can usually just run this test and see what we got. So as you can see, there's the answer. So this array of integers has two subarrays that qualify. The first is the subarray of 2, 3, and 4. So 2, 3, and 4 add up to 9. So they qualify. And then the next one that qualifies is 4 and 5. So let's get to it. This is just a function that's going to run the test. And here's the code. Now, I have 3 versions here. The first one is sort of similar to what I did in the interview, and even this one's even better than what I did. We were given a half an hour. My biggest problem, and for anybody out there, just note that a lot of time interviewers will not give you a debugger, and I am getting better very quickly without the debugger, but I really need a debugger right now. So you'll know when you've reached the pinnacle of your you've really conquered LeetCode if you do it with no debugger, just all system prints, but I just find the debugger so much more fun and so much easier to use. But I understand where they're coming from, again, trying to see how you think. So this really gets me nowhere. If we run it, it doesn't provide any answer. Everything fails. Okay, so 1 passes, but the empty array. So after the interview, when my nerves relaxed and I sat down and whiteboarded the problem. I realized that the consecutive nature of the problem makes the solution a lot easier to code. And I came up with this solution. Now again, I like to label my pointers clearly, so left and left plus 1. As we're looping through, I grab the current value of P1 and add it to initialize the current to the initial sum, and prep an array list for any numbers that we have visited, so that we could add them to our subarray list going out to the function. And this one it comes up in one of the tests where, in case the number that you visit is the same as the target value, so if the sum is the same as the target value, then you've found an array list of 1. So just break out. And again, we move the left plus 1 after each P1 to visit all numbers to see if we can find the consecutive nature. And of course, the length will have to be -1 so that you don't have an index out of bounds condition. And we just sum them up. And as we visit the numbers, even if they're correct or not, if we just add them to our nums visited array, and if they exist, if the sum actually equals the target, we're good. We can add that to our subarray list and break. Increment this is just incrementing the pointer along the loop after at P2, and then we want to increment P1 for the sliding window and reset left plus 1 P2. So then P1 would be here, whoops, and P2 would be here, and continue. And that's it. That if we run all the tests, everything passes with flying colors. This was a typical answer they were looking for. And I was really exciting algorithm to learn and to revisit after. And the sliding window problem, once there's a lot of YouTubers out there that talk about this, that once you understand sort of how to move through an array, you can use that creativity to make a lot of these problems happen. So look up sliding window, learn about the different pointers, whether you draw them from the front to back or back to front and meet in the middle, or you go left to right with 2. It's interesting. Now I cheated here on the last one. I decided to throw this problem into AI and see what it gave me, and of course, more learning, which never ends, by the way, as a software engineer, is going to be done with few amount of lines. And they had a lot nicer way, after using the P1 and P2 pointers, looping the same way we did. Once the target is found, once the current sum equals the target, then we can just cut that subarray from the indexes where they were found. So thought that was very interesting. So that's the advantage there of using the for loop instead of creating the pointers manually like I did. Now, I don't know what it is. I really like creating the pointers manually. It just helps clear my head. I often create my pointers and make my while loops and then add code. So that's all I got. On to the next.